different than exponential decay, I'm sorry, is a little different than exponential growth. The formula is a little different, and the idea is slightly different. Instead of increasing at a constant rate during exponential growth, in exponential decay, something decreases at a very fast rate. So the formula will look very, very similar, other than the only difference being for exponential decay, you have a minus sign in the formula rather than a plus sign. Okay, so the values are the same. A stands for the original amount. R stands for the rate of decay as a decimal. T stands for time. And then the Y is going to be the new amount, or the answer that you're going to get after a certain amount of time has passed. So in our story over here, the population of a town is decreasing at a rate of 1% per year. So our rate of decay is 1%, and as a decimal is 0.01. And our original amount says in 2000 there were 1,300 people. So A is 1,300 people for the original amount. Write an exponential decay function to model the situation, and then find the population in 2008. So that first part that they want us to do is they want us to fill in what we know into our equation. Y equals 1,300 times 1 minus 100th to the t power. 1 minus 100, or 100th, I'm sorry, is 0.99 to the t power. And all I did in my head was take 1 minus 100th and get 99 hundredths. Okay, so there's the equation. Now they want us to use that equation to find the population in 2008. Well, t is time, and the time that has passed is 8 years. So I don't want to put a year in there, like 2008. I want to put the number of years that have gone by. So time, usually in years. Could be in months, but in this case they gave it to us in years. So from 2000 to 2008 is 8 years. So I want to go back to my calculator, and I should have left my 99 hundredths up there, raised to the 8th power, and multiplied by 1,300. My number should go down because we're losing the population, it's decaying. We would be down to, I don't want a half a person, so I would say that would be around or approximately 1,200 people will be left in 2008. 1,199 and 56 hundredths. If I round that up, it'll be about 2,000. Okay, another type of exponential decay is called half-life, and you may have studied this in your science class already. But a half-life is basically how much time it takes for 1/2 of a substance to decay into another substance. So how long it takes for 1/2 of a substance to decay. And because we're talking about a half-life, the number in the formula that's being raised to the power is going to be 1/2. That's basically your rate there. Okay, so we've got our example. Fluorine 20 has a half-life of 11 seconds. This means it takes 11 seconds for 1/2 of the fluorine 20 to decay into another substance. Find the amount of fluorine 20 that would be left from a 40-gram sample after 44 seconds. Well, we want to know the final amount, so we want to know what the uppercase A stands for, or is equal to. The original amount is 40 grams. This time, if you look at time, time is the number of half-lives in a given period. Well, our period of time that we're given is 44 seconds. And after every 11 seconds, half of the substance disappears. So there are actually 4 half-lives that will take place in 44 seconds in this situation, because it takes 11 seconds for 1/2 of fluorine 20 to decay, And this is going on for 44 seconds. So that means there will be 4 half-lives. So the new amount will equal the original amount, which is 40, times 1/2 raised to the 4th power. Because of the half-life, we want to multiply the original 40 by half, but we're doing that 4 times because there's 4 half-lives that take place in 44 seconds for the fluorine 20. I want to do my power first. Order of operations, always do that power first. So, whoops, 1/2 raised to the 4th power is 625 thousandths. 10 thousandths, I should say. 625 10,000ths. And we're going to times that by 40. And we'll find out that there will only be 2.5 grams of fluorine 20 after 44 seconds. So 2.5 grams.